You ever wonder what's actually running behind the scenes of, say, your favorite Android app, or your online banking, or even the massive cloud systems that basically power the entire internet? Well, there's a really good chance it's an invisible giant, a technology that's been a cornerstone of our digital world for decades. Today, we're diving into Java and how its simple promise from way back in the 90s continues to shape our modern world.
I mean, the scale of Java is just staggering. We're not talking about some niche language for hobbyists here. No, we're talking about the absolute backbone of global commerce and technology. From the servers that are crunching financial transactions to the big data tools that analyze mountains of data sets, Java is the silent workhorse just keeping it all running.
For those large-scale, mission-critical applications, I'm talking about the kind of software that huge companies literally bet their entire business on. Java has been the #1 choice for a very long time. Its reputation for being stable, secure, and having this massive ecosystem of tools and developers, well, it's legendary in the corporate world.
So that really brings us to the core question of this whole explainer. How did this even happen? In a field that changes at lightning speed, how did one single language, born in the 90s, become so deeply embedded in the fabric of modern tech? Well, the answer starts with a pretty revolutionary promise.
All right, let's take a quick trip back in time. The early 1990s. It was kind of a messy digital landscape. You had Windows, Mac, all these different flavors of Unix, and if you wrote a program for one of them, it just flat out wouldn't work on the others without a massive rewrite. This was the exact problem Java was born to solve.
It all started with something called the Green Project over at Sun Microsystems. And the original goal wasn't even to power the internet. It was to create software for smart consumer electronics. A team led by James Gosling developed a new language, first called Oak, which would eventually launch in 1995 as Java, a name, fun fact, inspired by coffee.
And this right here, this is the brilliant, central idea that changed everything. Write once, run anywhere. It was a simple but incredibly powerful marketing slogan that just perfectly captured Java's core mission to free developers from being locked into a single operating system.
This mission was guided by 5 key principles. Okay, so it needed to be simple enough for programmers to pick up quickly. It had to be object-oriented, which is a powerful way of organizing code we'll touch on in a bit. It had to be robust and secure, to prevent common errors. And crucially, it had to be platform-independent without totally sacrificing performance. This was the blueprint for success.
So, how'd they pull it off? How did they actually make write once, run anywhere a reality? The answer lies in a really clever piece of technology at the very heart of the language. Let's take a look inside the Java machine.
Okay, here's how it works. A developer writes their Java code. Then, a compiler turns it not into machine code for a specific computer, but into this intermediate, universal format called bytecode. And that's where the magic happens in step 3.
The Java Virtual Machine, or JVM, basically acts as a universal translator. Every operating system, Windows, Mac, Linux, has its own special JVM. This JVM takes that universal bytecode and translates it into the native machine code that specific device understands. So here's the crucial point. You don't write code for Windows or Mac. You write code for the JVM, and the JVM just handles the rest.
Okay, so we've covered the concept, but what does writing Java code actually look like? Is it super complex and intimidating? Let's demystify it by looking at a classic first program. This is the classic hello world of programming. And even if you've never coded a day in your life, you can see the structure has a certain logic to it, right? You define a program, you define a starting point, and you give it a command. It's definitely structured and a bit verbose, which is actually a strength in big projects because it makes the code really clear and readable.
Now, this brilliantly illustrates one of Java's core ideas, object-oriented programming. Just think of a class as a blueprint. Say, the blueprint for a car. It defines what a car is. An object is the actual car you build from that blueprint. This whole approach is so powerful because it lets developers build really complex systems from reusable components, making the code way easier to manage and scale up.
Beyond its structure, Java was just designed to be incredibly reliable from the ground up. It has a garbage collector that automatically cleans up memory, which prevents a really common source of bugs. It has a system for handling errors gracefully, so programs don't just crash. And it has security features built right in. This focus on robustness is exactly why it became the go-to language for enterprise.
So, a language designed in the 90s with a solid foundation is one thing.
But staying relevant for over 25 years? That's another story entirely. Let's explore how Java evolved to meet the demands of the modern world.
Yeah, Java has not stood still. The language of 1995 was focused on things like desktop applications. Modern Java, it looks very different. It's incorporated powerful functional programming features, which allow for more concise, readable code. It's also been optimized for the cloud and for microservices, which are those small, independent services that work together to form a larger application. It's evolved without ever breaking its core promise of stability.
And where has that evolution led? Well, today, Java is everywhere. It's the foundation of the Android operating system that's probably in your pocket right now. It's a key player in the world of big data, with tools like Hadoop and Spark that analyze massive amounts of information. And it's a dominant force in building the cloud platforms and web services we all use every single day.
So, what's the takeaway here? Java started with a goal of running on smart devices, a vision that was maybe a little ahead of its time. But the principles it was built on, portability, security, and robustness, they proved to be exactly what the world needed for the web, mobile, and cloud revolutions that followed. Its core philosophy was just timeless.
And that leaves us with a final thought. The story of Java isn't just about code. It's about endurance. It really prompts a bigger question for all of us to think about. In a world where new technologies emerge and then fade away every single year, what are the fundamental principles that make a technology truly last for generations? What do you think?